I'm Tracy Jackson. I'm your secondary math TOSA, and in this session, we're going to be talking about the statistics standards from middle school all the way through high school, so that progression. And we're going to do that using a technology called Desmos. Desmos is a free graphing calculator that you can use for all kinds of graphing, including box plots and histograms, and things that we use for our statistics standards in order to visualize our data. Now, this is an interactive session, so regardless of what grade you teach, I encourage you to go through all of the different activities that we're going to be doing. And to do that, you will need access to some data that we'll be using, as well as the Desmos graphing calculator. So the link below is, just type that into your browser, bit.ly/PUSD lowercase, stats uppercase, and that will give you access to the data that we're going to be using, that you're going to copy and paste and put into Desmos. You will also want to go to desmos.com. You go to desmos.com and you'll come to a screen where it asks you about a graphing calculator. This is different than Activity Builder. So this is the graphing calculator platform. You're going to click graphing calculator. And once you do that, it should bring you to something that looks like this. So you're going to be using that as we go along through all of the progression. We're going to start with sixth grade. So that's where they start really looking at some of that data. So they start doing box plots. They talk about measures of center, median versus mean. They're even analyzing that in sixth grade, not to mastery, because they see that again in integrated 1. They also start graphing histograms and box plots and even talk about skew. They are also introduced to the idea of variability and not standard deviation at this point. They do something that I hadn't heard of before called mean absolute deviation. So it's called the MAD, and it's really just taking the absolute value instead of squaring the values. So that's what they talk about. It's a precursor to standard deviation. They also talk about IQR and range. So they have a lot of information that they're starting in sixth grade that they then look at again in integrated 1 and build on a little bit, and then again in integrated 3, where it's that critical standard of mastering the idea of looking at data. So let's take a look at sixth grade. Now again, you might want to access this data through that bit.ly address, because that will have the data there for you. But I'm also going to show you how to copy and paste it from a PDF on your worksheet so that you're able to do that with the data we're not talking about today. So let's take a look at the sixth grade book. So you'll go ahead and find your electronic access to the lab sheets, and you can do that lots of different ways. I'm going to go through Realize. And then once I'm there, I'm just going to choose my correct text, and I want the e-text and sixth grade teacher edition. I'm going to open it in a new window and look at the table of contents because I want to go to data about us. And let's first look at investigation 1. Now in investigation 1, they start comparing data, and they do that with dot plots. And then I want to look at Launch, Explore, Summarize, because I'll get my lab sheets that way. And then I'm going to use these lab sheets to get my data for Desmos. Now, I could just type them all in. It just takes a long time. If you choose to do that, have one student at the computer and then one student reading the data to them. This makes it a lot easier. So I just clicked on it, and I'm holding it while I'm moving my mouse. And then once I have all the numbers highlighted, I can hit Command C or Control C. That will copy it. I'm going to paste it into my Desmos data here. And this is for the Chinese pen pals. And then I want the other set of data as well. So I'm going to go back over there, and instead I want the US students, and I'm going to click. Go all the way to 15. I'm holding, and now I let go, and they're all selected, and I hold down Command if it's a Mac and Control if it's a PC, and then I click C, and then I do the same thing for pasting. Now, Desmos likes them to have commas in between them, and right now we don't have any commas. But we can use like a little trick to put all of the commas in between there if we copy and paste data. So if we have a space in between, what we really want to do is replace the space. So we're going to use something, a little trick on there. If you're ever looking for anything, you use Control if you're on a PC or Command if you're on a Mac, and then F. So hold down the Control button or the Command button and click F. Now you see where it's finding things, and I want it to find all the spaces. So right now it's going to find spaces in between here, so I'll have to fix that. But then I want to have them replace it. So all of the spaces, I want them to replace it with a comma. So I'm going to click right here, these 3 dots, and then I want to replace with, I'm going to go ahead and put a comma right there. And then I want to replace all of them. So it's going to replace all the spaces with commas. So click Replace All, and then you're done. And you can see it also replaced this right here, but I can take that out. So now I have my data ready to go into Desmos. Now, if you don't want to type this all in, it is there all ready for you. So it is ready to go, and it is under, you can find it in the resource. So if you go to bit.ly/PUSD, and that's all lowercase, and then stats, all uppercase, you'll have a link to all of the data. So you could just copy and paste it from there. I just wanted to show you how you can copy data from just even a PDF and then make it a little bit easier for Desmos. And you can share that Google Doc with students so they can copy and paste the data as well. So that's what that looks like. So now make sure that you have the data, because we're going to go into Desmos and we're going to plot this stuff. So go ahead and copy the data. So again, highlight the data and then Command or Control C, and then we're going to go into Desmos. So go to desmos.com. You probably already have that open. You clicked the graphing calculator. And now you've got this. And so what you want to do is you want a list or a set of something. So you can name it anything you want. I'll name it C for Chinese, equals, and then you're going to use the square bracket. And then you see it's got a list. And then we just use Control or Command, and then V for paste. And it pastes all of those in there. Now we can make a dot plot. So we've got the ending square bracket here. And to make a dot plot in Desmos, it's really easy. We just type in dot plot and then parenthesis. Now notice that's not a square parenthesis. And then we type C inside there. And it makes that lovely dot plot. Now something you can do with Desmos is you can zoom and fit it. So it will zoom to fit that window. So I'm going to click that. And then it fits all of my data inside there. So that's my dot plot. This is my frequency, how often it occurred. And I can change the bin width, but I'm not going to change that for a dot plot. So this is what that would look like. And then we can also plot the other data. So we could either do a new Desmos graph and we could put them side by side, or we can plot it right next to it in a different color. So to change the color, we could just do this. Let's see, we want that to be red or green. And then we can do the same thing with our other set of data. So let's go to our other set of data. And we highlight it, Command C or Control C. And this is the US one, so I'm just going to call it U. Square bracket, and then Command or Control B. And now we have that. So that now says that U is all of this list. And so then I want to compare them. So I'm going to do a dot plot, and I could do this in another Desmos graph if I wanted to, if I wanted them side by side. And then I can put U. So now we can see the dot plots next to each other. Let's go ahead and zoom fit to that, and we can see them. So we can erase them and then see them again. So there is a little bit of overlap, but not a whole lot as far as name length. So then students move on to investigation 2, where they really look at the mean. And in there, they do a visual comparison using cubes of what does mean actually mean. And they start looking at sample distributions with the same mean, but different kinds of data. So different data points that have the same mean. In problem 2.3, they look at the choices between mean and median. So let's use Desmos to do our calculations for mean and median. Again, we can either copy and paste the data, or you can use the data that's already in the resource sheet. So the data here, we can just look at the skateboard prices. So in 2.3, they're looking and comparing the stores. We can copy and paste, and then take out the commas, just like we did before. Now remember, you find the data just by clicking here, session data, and it should pull up something like this. So I replaced the commas so they're in kind of weird places here, but we can go ahead and copy that data and put it into our Desmos graph. And now I have a new Desmos graph that I put in here. And let's call this store A equals bracket. And then same with B and C. And you'll want to use capital letters because lowercase letters indicate that you want a slider. So use a capital letter to name your data sets. And then we could do dot plots for each of those. And again, we could do these on separate graphs if we wanted to compare them side by side. And again, we can zoom so that we can see all of the data on there and look at different ones too. We don't have to have them all marked. Now, once students understand how to calculate the mean, there's no reason to do it by hand after that. Otherwise, they're just blindly calculating. So once they have done that a couple of times and they understand it, you can use Desmos to find the mean. Just by typing mean. You can also do this to find the median. Now, if you look at the mean between B and C, you can see that that differs quite a bit. However, if you look at the medians, they are the same. So it's a great discussion to talk about measures of center and when you're using what measure of center, depending on where the mean is in relationship to the median. So you can see that C over here has this outlier of 200 that's pulling the mean to the right a little bit more. Whereas our data for B is pretty symmetrical around this 50. And that's where we can start the conversation of the mean really being affected by those outliers and talk about skew. So the mean being to the right of the median causes it to be skewed to the right because that outlier is pulling it to the right. Sixth grade, in Investigation 3, is where they start to talk about what the mean absolute deviation is. And they're given this great diagram which talks about here being the mean and then the absolute value of the distance from the mean. So they're averaging the distances away from the mean. So that's where they first start to talk about variation. And then they go on to Investigation 4 and use both box plots and histograms to describe the data. So we're going to just do a few of those things on Desmos with the data we had before. There's no reason for us to put in new data, although each of these has different data that they're looking at. So if we go onto our Desmos graph that we already constructed, we can take a look at our different values. So remember, these are the skateboard prices. So I'm going to go ahead and uncheck everything, but we still have that data inside there. So we've got the A, B, C, D. So let's talk about how to do both box plots and histograms. So first, let's do a histogram. And we just type in histogram, and it's lowercase. And then let's go ahead and compare B and C, since we were looking at those before. So we put B in here, and then we can see different options we have. Now, our book in integrated one, and also in our middle school, does the left bin alignment, and you can play around with that to see what that does. And then we need to change our bin width. And so depending on how many values, it's about the square root of however many values. And I think our values were around 18 or something like that. Yeah, 18, 17. So if we do the square root, it's about 4, or I mean, we could even say 5. Now, when we click that, we click bin width, we can see it made a comma right here. So this is going to also tell us our bin width. So we could have put that in there originally. And that's how many bins are going to be in there. And again, we can just do the zoom to fit, and we can see what's happening with our bins here. Going here to the graph settings, and we can go by different steps, maybe by 20s. And then we can see right where that is going to be. Okay, so now we've got our histogram on here, so we can take a look at what that histogram is. Now, the way that the histograms work, so say you had, like, here's our value of 10. This would be 15. So these are counting by 5s, 10, 15, 20. So right here, if a value is at 15, it will be moved into this bin, which is between 15 and 20. So that count, if it lands right on there, will be pushed over here to the right. So this is the way our histogram works. And then we can also see what a box plot of the same thing would look like. So we can compare that. And we just type in box plot. And now Desmos does outliers. So you can exclude outliers or you can include outliers. And then we probably want to offset this, and we want to, we can change the height, which shrinks it or makes it taller. Let me show you just what that does. Like, we can make it really tall, but we don't really need to. And then we can offset it. So remember, with the box plot, it's really just the x-axis that matters. The y-axis doesn't have any real meaning. With the histogram, the y-axis represents the frequency, how many occurred. So we can offset this easily. Maybe let's put it at 3, maybe 3.5, maybe even further. So then we can take a look at that on here. So we can exclude outliers, we can include outliers, and we can see that this one doesn't have any outliers on here. Otherwise, it would show up as a little dot. So that's our box plot for B. And then if we wanted to, we could do the same thing with C. So we could do histogram. And then let's maybe color these the same. Let's color this red too. Histogram of C. And then let's go ahead and change the bin width to the same. And left centered. And then here, box plot of C. And now we can see that outlier. Let's offset this as well. Maybe let's make this also green. Well, maybe not green. Let's maybe make it black so that you can tell the difference between those, in case you have colorblind, if you're colorblind. Okay, so here we go. And then let's offset this. Maybe let's put it above it. So maybe 4, maybe 5. Let's see. And then we can zoom out a little bit. Okay, so now we can compare these. And then we can also take away this histogram to take a look at that. So now if we wanted to, we could graph these in separate Desmos graphs, we would just pull up another Desmos graph and put them side by side with each other. But if they're plotted on the same graph, we can unclick and click to compare them. Now, because we talked about the MAD, we can also calculate that on here. So we just type in MAD. So after students have calculated this, and we can see the difference. We can see C has more variability than B does with that measure. There are a couple of other things we can do. So we can find the total. We can add the total of all the values together. We just type in total B. So before you're calculating mean, you can actually have them do that total if you wanted to and go through that process. That helps with some of the checksum things. You can also find the min and the max. So you just type in min, and then you can type in max, and that will find the min and the max of a list that you have in there. So you have that in there, and then you can easily find the range. You can find the quartiles. So if you want to do quartile, and then whatever when you're looking at B, if we want to talk about B, quartile 1, and then quartile B3. So that gives you your IQR, your interquartile range, where 50% of your data is. So you can use those calculations on Desmos to kind of explore the calculations and work with that. You could even use quartile B, 2 to find the median, although remember we can just type in median to find that. We can actually get all of these in a table, and we can just type in stats and then B, and it will give us the minimum, quartile 1, the median, quartile 3, and the max, and then they'll be all together. So those are some of the operations you can do in Desmos, and those will carry through to integrated 1. So you will do the same sort of thing with box plots and histograms and use those when you go through that chapter 10 in integrated 1, comparing those 40 holes of golf, all of that data in there. So the same sort of thing applies. We will add standard deviation to that though. So those are just some of the commands you can use on Desmos and some ways you can visualize the data using both histograms and box plots. So you notice in 7th grade, it looks very similar to 6th grade. We have a lot of the same things that are revisited in the investigation called samples and populations. The big difference is that sampling method. So really looking at, is it a representative sample of our population? So that will tie in nicely to integrated 3 when you're looking at different kinds of samples and what they represent. So the other thing is it ties in nicely to proportional reasoning. So when they take a sample and then they can say things about the population. So 7th grade, you'll be using Desmos much in the same way that you used Desmos in 6th grade. But in 8th grade, we moved to another variable. So we moved to bivariate, 2 variable data. And we can look at that in the categorical way when we're looking at two-way tables. And again, that ties into our understanding of percents and proportionality. And then bivariate data with numerical values. And so we're plotting those on a scatter plot. So they are introduced to scatter plots and introduced to line of best fit. They do stop there. They don't go to the least squares regression line. They kind of eyeball the line of best fit. But they talk about residuals and correlation coefficient. So they will have some of that exposure before they get to integrated 1 in chapter 4. They also make predictions with their line. And so that's tying it into what they understand about slope and y-intercept. And so the scatter plot is a really nice connection in 8th grade. They do a little bit of variability, not a whole lot. They revisit MAD, and maybe they have an intro to standard deviation. We want to take a look at what bivariate data looks like in Desmos. So I want to show you that. So go ahead and go to the link, the resources link with the data, and pull up the data for 8th grade. Now we're looking at this bivariate numerical data, and we can take a look at that in Desmos as well. So if you go and collect the data for the 8th grade, it looks like this. So this is looking at race, time, and age. And you can copy this data directly into Desmos. So let's go ahead and make a scatter plot. So you just want to hold and click, and you just want to get all of the data from those two columns. Let's make sure we got it all. And then hit Control or Command C. And then we're just going to go to desmos.com. And then here we can actually just paste it and it will make the table for us. So it automatically makes that table. If you wanted to have the students make it on their own, you could do that. All you do is click here and click Add Item and then click Table, and it will make a table. Now that subscript is going to come into play when we're making the least squares regression line. We're not doing that right now, so it's not a big deal. But then we can have this data and students can have the data plotted on there. Now you might wish to have a movable line so students can move the line around. If you look in the resources, you can see this movable line graph. If you go ahead and click on that, it'll open it up. And you can use that movable line to have students work on that data. So again, I'm just going to go into one right here and click paste. So Command V, and it's going to put that data on there. And now students can move the line around to see kind of where they think it best fits. So that's a movable line. And that's helpful in scatter plots when you want students to just kind of eyeball that line of best fit. And they can touch the points on the line for the predicting as well. So they can move around over here and they can use those to help predict where things are happening. And they can click on the data points and see where they are and the meaning for them. And this double click to get them off. Now the other thing I want to show you is the ability to visualize what a residual is. So if you go to the resources again, you can see where it says dynamic graph to show residuals. If you click on that, it will have those residuals on there. So it has both a movable line, and then you can also move around the data points to talk about like what the residual means. So it's graphing the residuals on here, and you can see this is a negative residual, this is a positive residual, so they can visualize it a little bit better. So that's also in the resources for Math 8. Now we're going to build on this as we get to integrated 1. So we're going to do the least squares regression line and talk about how to do regression in Desmos. Integrated 1 is a key course for understanding the bivariate numerical data, especially in linear form. So this is really the last time they'll have a key focus on that. And they'll move from line of best fit into the least squares regression line, where they're taking those residuals, they're squaring them, and then finding the overall least sum of those areas in order to find the absolute line of best fit, the LSRL. They'll also take a look at residuals, but not only that, they'll use residual plots to determine what form the model should be. Should it be a linear model? So they'll go into depth on what those residual plots mean. In addition, they'll look at correlation again. They started this in 8th grade, but they'll look at it again. And another key component of integrated 1 is association versus causation. So just because something's associated doesn't mean one variable causes the other. They'll also continue to explore bivariate data, categorical data in two-way tables, and they'll continue that through integrated 2 as well. The univariate data they'll see again in integrated 3 when they're working through that, and they'll take that to the next level where they're talking about relative frequency histograms. So they'll see all of those again, but they do really focus on standard deviation, and it fits really well because if they're talking about the least squares regression line where they're squaring those residuals and they're also squaring the distance from the mean. So it fits in really well with this and connects a little bit to them trying to get that positive result for the standard deviation. So lots to talk about in integrated 1, and Desmos is really powerful for regression equations. And so we can take a look at some of those ideas. The first one I want you to take a look at, we're going to take a look at 2 big ideas here. And then we'll go back to the dry ice one. So we're going to go through all of these graphs. So the conceptual LSRL, and so you'll want to click on that. And then also the Desmos basketball. And then the last one, the dry ice. So we're going to go through in order those three. So you'll want to have those open. And again, you could just use the straight Desmos calculator to do this, and even teach students that they can graph that LSRL. They don't need these pre-done graphs. So let's first take a look at the conceptual LSRL graph. So this Desmos graph gives students a good idea of where the least squares regression line comes from. Now this is also in our textbook, so it's linked in there, but it's a great discovery activity. I would highly encourage you to have students have Chromebooks to play with this at first. Have them think about like maybe where the line should go and take a look at it, like try and have that line of best fit. And then have them click the residuals just so they can see the residuals. So once they see the residuals, they might make some adjustments. Say they think maybe here, maybe down a little bit more. And once they see the residuals, you're going to show them the residuals squared. And it's actually going to make a square for you. So now we've got the squares on there, and Desmos, they wrote a little sum of squares, so they're adding all the squares together, and you can see that sum of squares. So as you move the line, the sum of the squares changes. So you've got the sum of the residuals and the sum of the residual squared. And so you can move it around until you get the absolute lowest you think you can get. And students will love to play this game. They think it's very fun. So have them get as close as they can, and you can even kind of keep a running tally. And tell them that this line, the line that they're creating, is actually the one that has the sum of the least squares, which is the least squares regression line. So then you can open up the least squares regression line after that. So if you click this, it'll show the least squares regression line, and they can see kind of how close, and they can even move it to be on there and can see that the sum of the residuals squared is the least that it could possibly be there. So that's just a fun way to start the understanding of what the best line of fit is. So next, let's go ahead and look at the Desmos basketball graph. This is for section 414. And this you can do a whole lot in there. So this one does have that movable line on there, which is why I like it. Kind of let students play with it a little bit. Like, what does that outlier do? Play around with it a little bit, and it has the data already entered. The only thing I don't like about this is it kind of takes away from the students just being able to use Desmos as a tool and entering the data, but it's nice to have it already entered in there. So they're drawing that line of best fit that they think is going to be there. Oh, there's another data point right there. So remember, that will zoom fit my data. And then they can answer these questions if you want them to ask that. But then we really want them to find the least squares regression line. Now let's go back and look at this table, because that's going to be important. So here we have this x sub 1 and this y sub 1. Now that's important when you're writing your least squares regression. If you make a couple of tables, sometimes that value will change like to a 2, and then you'll get an error. You won't be able to type it in. Now the way you type in, the way you have Desmos calculate that, is you type in y and then just the number 1, and it'll automatically put it down below. And then you want to type in the tilde. Now the tilde is a little wavy line. It is on top of the apostrophe, and it's probably below your escape key, and it looks like this. And so that your y1, this is our predicting equation, is and then this little wavy line, this tilde, mx1, and then you don't have to type anything to make the 1 go below, and then plus b. Okay, so that's going to give us some information. That gives us r, which is the correlation coefficient, which we talk about. That also gives us our slope and our y-intercept. So if they were to write this equation, depending on where they're rounding to, they would have a y hat, or a y equals m, which is 0.59 x minus 208.7, or depending on how many decimal places you want to go. But then you've got your equation that's going to model and predict what's going to happen here. And so you can see my line was a little bit off there. I can go ahead and fix that. So now I might want to plot the residuals. So if I click right here, it's going to both calculate and plot them on the graph. So click plot, And you can see those residuals. Now remember, residuals are how far that distance is from the line. And this one's below, so that residual is negative. So our x-axis is the same, and the y-axis, instead of the actual points scored, it's the change in the points scored, or the residuals. Okay, so then I can actually find them up here. There we go. So I can actually find them up here, and it has calculated all of those residuals for me. Now in this one, we're calculating the sum of the residuals and the residuals squared. Now Desmos will allow us to do that. So we can actually use some of the things we learned before, and we can say total. And so notice it changed from italics, that means it's recognized, E1. And so that added all the residuals up. Look, my residuals are pretty close to 0. And we can do the same here with total, and we can do the residuals squared. So E1 and then squared. So I want to square the residual, and then I want to find the total of them all added together. So that's the sum of my residuals squared. Now let's say I want to just look at my residual plot. So I can go back up here and take away the black. I can also take away the line. And then I might want to zoom in to kind of look at this right here, because I can see over here, like, really I don't need to be any greater than 1,000. So I do that just by using the wrench. And I might want to go from negative 1,000 to positive 1,000. And then I can see my residual plot a little bit better. Now that's going to be important when we look at the dry ice problem, because this residual plot, just because my residuals are close to 0, that doesn't mean that a line is the best model. And we're going to see that in our dry ice one when we see the residual plot and we really look at that. So you do need to teach them to resize it in order for the dry ice one. So let's go to that one. So over here, I'm just going to click on the dry ice graph. And again, students could enter all of this data, but it's already in there and we can click to it from our book. So that's really nice. So here we've got this. Here's our line, and it's x1, y1. And it looks like they'd already typed the equation. I would probably take that equation out and have students type that. So you could just get rid of it and then save this and then share this graph. Maybe I will actually change that on the resources. So then you're going to type again y1 and then tilde mx1 plus b. Okay, so that looks really good. That looks like a linear relationship right there. We've got our correlation is like correlation squared is near 1, and our r is really close to -1. So nice relationship there. We can plot our residuals. We see our slope, and we see our y-intercept here. So we have the equation, our prediction equation, our model equation. So let's go ahead and plot the residuals. And look, our residuals look really close to 0. We can even total them. So total E1, and really, really close to 0. So that's great. We can see them up here. Look how close they are to 0. But then when we look at the residual plot, we see something interesting. So right here, we can't really see a whole lot. We can see sort of where we're going to put our residuals to. Like really, let's see, 0.2 might be the largest residual, and -0.2 probably the smallest or close to. So I'm going to go ahead and click this wrench. And the x-axis, remember, doesn't change. So the y-axis, -0.2, maybe 0.25, just so we can see a little bit better. And here, 0.25. So when we do that, we can see a curve forming. So we see a pattern in here. We have these are above, and then in the center is all below. So this curve pattern lets us know that a linear model might not be the best model for this because we've got a curve pattern in the residuals. So that's a big idea from integrated one, is really looking at those residual plots and understanding what they mean. So this, if we imagine our LSRL, this would be this far above the line, the model line, and this one would be this far below the model line. So that's a look at all the bivariate numerical data. And again, they do visit in chapter 10, histograms and box plots and mean and median and all those kinds of things, including standard deviation. So the things we kind of talked about before, but also including standard deviation. So maybe let's go over just how to type in standard deviation. Integrated 2 mostly connects probability with all kinds of other things students are learning. They look at categorical data in two-way tables and talk about whether there's an association or not. They explore expected value. They looked at the fundamental counting principle, combinations and permutations. They do a little bit of regression. They do this with quadratics, and it works much in the same way as linear. They just type in y1 tilde and then ax1 squared plus bx plus c, or they could even put that in vertex form and find the regression equation for the quadratic. But it's a very small part. Mostly they're focusing on probability. Now, Desmos allows you to calculate permutations and combinations as well. Let's look at one of the activity builders that's included in the resource page. So here is our resource page, and we're just going to go to the ice cream combination and permutations activity. So let's go over here to the 1013 data. That's about the procedures, and we'll look at that in terms of standard deviation. So we can take these two procedures, and again, we can just copy and paste the data. So copy, and then go into Desmos, and let's call this, I think it was C1, capital letters, square brackets, and then I think it was C9, let's go back and look, C7. So that was C2 and C7, so we'll rename those. C7. Okay, so we can take a look at these same procedures, and we can talk about the variability with standard deviation. So let's go ahead and look at what this data looks like, at least, so we can kind of get an idea. So maybe let's plot a histogram for each. And let's go ahead and make these maybe 4. Bin width of 4. Okay, and then we want to zoom to fit it because we can't really see it very well. We want to fit this one. This one's bigger. Okay, so now we can take a look at what we're seeing here. So if we look and we try and make a guess where these things are, we can see that probably this one up here is going to have, the C2 is going to have more variability. And whereas histogram, this one right here, it's kind of packed all in the middle. So we could also take a look at the box plots and dot plots of this if we wanted to. All right, so we can see these outliers over here. We can also look at the standard deviation, and we expect it to be more in the purple one. So this is the entire population. This is all of the data we have. We're not picking a few things on there, and it matters by what we type in here. So we want the standard deviation of the population. It's a different calculation if you do a sample. And then we want C2, and then we want the standard deviation C7. And we can see that we have more variability in C2. The same would be true if we calculated the MAD, which we could also do in here. But that's how you calculate standard deviation in Desmos, and students will be doing that in Chapter 10 of Integrated 1. Integrated 2 mostly connects probability with all kinds of other things students are learning. They look at categorical data in two-way tables and talk about whether there's an association or not. They explore expected value. They looked at the fundamental counting principle, combinations and permutations. They do a little bit of regression. They do this with quadratics, and it works much in the same way as linear. They just type in y1 tilde and then ax1 squared plus bx plus c, or they could even put that in vertex form and find the regression equation for the quadratic. But it's a very small part. Mostly they're focusing on probability. Now, Desmos allows you to calculate permutations and combinations as well. Let's look at one of the activity builders that's included in the resource page. So here is our resource page, and we're just going to go to the ice cream combination and permutations activity. So we're looking at one of the Desmos activities, and this one kind of helps understand the difference between combinations versus permutation. So if you were thinking about choosing the 3 ice cream scoops to put them in, it doesn't really matter which one you choose first. Like, they're all going to end up the same way. We can turn the bowl around and it looks the same way. So it doesn't really matter inside of a bowl. However, if you put them inside of a cone, you might not like your strawberry to drip on top. So they're calling this a different order than something maybe like this. So this is a different ice cream cone. So in this way, we can talk about the differences between permutations and combinations, and Desmos will help us calculate those. So we can just go over here, and then we need this keypad. This keypad will have some interesting things for you to look at. And we'll go to stats, and then let's talk about the bowl first. Let's talk about how many combinations we might have there. So I click this right here, and students have already experienced what combinations are before you're showing them how to do this on Desmos. You don't want them just to type it in there. You want them to come up with that formula on their own. But once they do, they can use Desmos for that. And so the number is the total number of possibilities. So in this case, there were 6. And then choose 3. And that will give us the number of combinations. Now, permutations, where the order matters on the ice cream cone, like vanilla, chocolate, strawberry, is different than strawberry, vanilla, chocolate. That's going to give us many more possibilities. So we can do that as well. And we can just use the permutation from stats here. So 6, choose 3. And that's going to give us a much higher number because of those differences. So you can use Desmos to make those probability calculations as well. So integrated 3 is where everything compiles together and their understanding is kind of firmed up with univariate data. So students again look at histograms and box plots, and this time they create relative frequency histograms, and then when appropriate, connect those to the normal curve. Desmos allows us to do all of that. In addition, in Chapter 6, they look at margin of error, hypothesis testing, and then different kinds of samples, so connecting back to what they learned in 7th grade. So Integrated 3 is the place where this all comes together. All of the data understanding and modeling is one of the 4 main standards of Integrated 3. And so it really is a big part of that. It takes up 2 chapters of Integrated 3. So let's take a look at how Desmos can help us with that. So let's take a look at Integrated 3, and we'll look at the data there and go through some of the things that we can use Desmos for. So I'm clicking on the data, and I'm going to go ahead and take the race time data. So this is from Chapter 4, and I'm going to go ahead and copy and paste this whole thing. Look, it already has the square brackets for me. So I'm going to copy that, and I'm going to go ahead and place it into the Desmos calculator. Now, we can do all kinds of things with this. We could do a box plot for A, and then we can't see it right now because we haven't zoom fit it. So we can zoom fit it. We can see the outliers there. We can also do a histogram. Let's make it left centered. We'll make it blue. Okay, and then here in Integrated 3, they start to talk about not just the counts, but the proportion. So they go ahead and take percentages of each of them. And that's where you get this relative histogram. And so they take those percentages, and then when you look at it, of course, the highest is going to be 1. So we can't really see it here, but we can go ahead and click the little zoom fit, and then we can see it a little bit better. So here's our histogram, and we can see our highest percentage up here is 1. And that will help sort of translate this idea into a normal curve. And so we can also talk about finding the mean of A, and we can find the standard deviation. And this is a population of A. And once we do that, this will connect to what the normal curve looks like. If the data is symmetrical like this, we can represent it with a normal curve. And the way Desmos allows you to do that is you just type in normal dist and then parentheses, and it automatically defaults to this normal curve of 0 of the mean and the standard deviation of a 1. And we don't talk too much about that in integrated 3, but we can put in our mean and our standard deviation, and then 0.96. Okay, so now we've got this normal curve, and we can find the probability under there. So let me go ahead and take away, we can see kind of how this represents in our histogram. We sort of see the shape of that. Let's go ahead and take away the histogram and talk about how we can find the probability under the curve. So Desmos allows us to do that as well. So we can just click this button, and it automatically defaults from -infinity to infinity, and the probability is 1, 100% it's going to be in there. But we can change these values as well. So if we wanted to know, what's the probability from 20 to 22? So let's go from 20 to 22. And it will give us that probability. And so we can do all sorts of things with that. We can do, we can go the other way too. So we can go from 24 to 26. Or we can do a middle one, 22 to 24. And we can also look at what it looks like 1 standard deviation away from the mean. So let's go ahead and default. Like if you leave this blank, it automatically defaults to -infinity and +infinity. You can type INFT, and it will do infinity as well, but it'll default if you just leave it blank. Okay, so let's go ahead and take that away for a minute, and let's graph the mean. So let's do x equals, our mean was 23.2175. Okay, so we've got our mean in there, and then let's look at what 1 standard deviation away from that is. So we have our standard deviation is about 0.96, so x equals that minus, 0.96, and x equals that plus 0.96. So if we take a look at that, and then we find the probability in between these two values, we get that 68% rule. And we can do this with 2 standard deviations as well. We just put a 2 in front of each of these and multiply it. So let's go ahead and find the cumulative probability between the two, and students will be able to see this. So 22.26, about. And then 24.17 or 18. And then we can see that 68% right here. And we could do that also with 2 standard deviations. We would just over here 2 times. So 2 and then the times sign. And same here. And then we can see where that is, and we can use those values up here and see that that works as well. So that's how you can use the normal distribution to graph a normal curve on Desmos. Now the other thing you can do, which we don't get into it too much, but we talk about binomial distribution. So let's get rid of all these. Okay, so we can type in the binomial distribution. Okay, and then we need the number of trials. And then we also need the probability of success. So let's say 40 trials, probability of success, let's say, is 0.4. Okay, and then we want to zoom fit it so we can see kind of what it looks like. And we can do the same thing here. So let's say we want to know the successes between 10 and 15. So what would that look like? 10 and 15. And then we can see those, so we can visually see where those show up on the graph. So that's a kind of a cool way to use the binomial distribution when we have 40 trials at a success rate of 40%. So another thing we could do, we could even put, if we wanted to, put a slider in here. And we can have A between 0 and 1. Step 0.1. And then we can play. And we can see what happens as we change that success probability. And can compare it to how it looks for a normal curve. So later on, we don't do this in integrated 3, but you can even do the t distribution. And you need the number of degrees of freedom, and that will also graph for you. So there's lots of ways we can use Desmos with statistics. So these are just some of the examples from integrated 3, really up until here when we're looking at that normal curve. So that normal dist is a handy thing to have for integrated 3. I hope you enjoyed following the progression from middle school to high school about those statistics concepts. It was definitely something I didn't really understand until we adopted this integrated curriculum. And it's been really great to be able to see them all the way from 6th grade to integrated 3 and then beyond. I also hope you enjoyed playing around with Desmos. It's a powerful learning tool that helps us visualize data and oftentimes helps us speed up some things. So the students aren't bogged down calculating or trying to draw things. Instead, they're doing the interpretation, which is a much higher level skill. Well, I hope you have a great start to your year, and I hope you enjoy teaching your students how to use Desmos for statistics.